will design subtractor circuit. Okay. Here subtractor is the combinational circuit. The purpose is it will perform the operation of subtraction. Right. Again, based on number of bits which are there in that, the subtractor can be classified into two types: half subtractor and full subtractor. Half subtractor means here the subtraction operation is performed between two binary bits. In the case of full subtractor, the subtraction operation is performed between three binary bits. Right? Now the thing is, we need to design this half subtractor circuit by using logic gates. Similarly, full subtractor circuit using logic gates. Half subtractor is a combinational circuit. So I am considering one block of half subtractor. This block consists of combination of logic gates. As it performs operation, subtraction operation between two bits, I am assuming two bits are A and B. These are the input bits. Right? After subtraction of A and B, let the subtraction means it will perform the operation A minus B. Then we will expect output as difference and borrow. Right? Now, so for these inputs, we need to get this output value. For that, we need to design the logic diagram for this half subtractor. Right? So to get that logic diagram, initially we require truth table. Truth table gives the relation between inputs and outputs. Here the inputs are A and B and outputs are difference and borrow. So as we are having two inputs, the possible combinations with two inputs are 2 square means 4, which are 0 0, 0 1, 1 0, 1 1. Now we need to develop this output values, right? So as difference is what here? A minus B. So we'll see. First we need to perform 0 minus 0. Then obviously difference is 0 and borrow is 0. See, the second function is what? 0 minus 1. We cannot subtract one value from 0. So during that case, we need to take a borrow value, right? So I am assuming borrow is 1, right? When we are taking the borrow value from somewhere here, now which is equal to 2, means that value is always equal to radix value. So 2 minus 1, you will get the difference value is also 1. Now third function C, 1 minus 0 means the difference value is 0 and borrow is also 0. And fourth one is what? 1 minus 1. So the difference is 0 and borrow is also 0. Right. With this, we know the output values, right? So from this, we'll write the logic expression. logic expression for difference and borrow. Here just consider only when output value is high. Okay. In the difference, these two cases, the output value is high. So first case is what? When A is 0 and B is 1, means A bar dot B. 0, A is 0. So I am representing A bar and B. Then you will get the output as high. Or there is a one more possibility to get output high. That is what? A and B is 0, means complemented form. So A, B bar. That is logic expression for difference. Coming to borrow, borrow value is high for only one case. That is what? A bar, B. So borrow is high for only one case, that is A bar and B. Now we know the logic expression, right? And one more, if you observe this function, A bar B plus AB bar, we can write as A exclusive or B, right? So as I know the output values, I can develop the logic diagram. For difference, take A and B inputs and function is exclusive OR, so give it to one XOR gate so that you will get A exclusive OR B, which is nothing but difference. The next one is what? Borrow is nothing but A bar B. So take A input and give it to one NOT gate and take B input, give it to one AND, so that you will get A bar dot B. This is what? Borrow function. So in this way we can find this combinational circuit by using logic gates. Now we will design full subtractor circuit. The purpose of full subtractor is it will perform the operation subtraction. Full means it performs the subtraction operation between 3 bits. Okay. So this is also we can represent with one combinational circuit. Let's take this is full subtractor. As it performs the subtraction operation between 3 bits, so I am assuming input we are having 3 bits which are A, B, C. When we are performing the subtraction, two possible outputs are there, which are difference and borrow. Right? So now the thing is we need to find this combination of logic circuits to get the difference and borrow values for these inputs. Okay. To develop the logic diagram, basically we require truth table, so take the input here, inputs and outputs. Inputs are A, B and C. Outputs are difference and borrow. Okay. See, as we are having 3 inputs, then in a truth table 2 cube possible combinations are there, means 8 possible combinations, which are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. 8 possible combinations. For all these combinations, we need to find what is the difference value and what is the borrow value. Here the difference is what? Initially, we need to perform a difference between A minus B minus with C. I am writing A minus B minus C like this. Initially it is A minus B, then the resultant with minus C. Okay? Yeah, just see. 0 minus 0, initially A minus B, right? 0 minus 0, you will get 0. So 0 minus 0, again the difference is 0, borrow is 0. Borrow is not required here. So 0 minus 0, second case also, so 0. Now we need to subtract 0 minus 1, right? What? 0 minus 1. So subtraction of 1 from 0 is difficult. So during this case, we need to take the borrow value. When we are taking the borrow value, that is equivalent to that equivalent value is always radix. So 2 minus 1 you will get 1. The difference value is 1. See here, we need to perform 0 minus 1 initially. So again I will take the borrow as 1 so that your difference value is also 1. So 1 minus 0, you will get 1. And fourth case, 0 minus 1. Here also we require borrow value, right? So 0 minus 1 means borrow 1, and similarly the difference value is also 1. Now 1 minus 1, you will get 0. So 1 minus 0, here there is no need of borrow, directly I can write the difference value. In this case, 1 minus 0 means the difference value is 1, right? Again 1 minus 1, so the difference is 0, borrow is 0. 1 minus 1, 0, right? Again 0 minus 0. So 1 minus 1, the difference is 0, right, for the first case. Then 0 minus 1, so you require a borrow value to get 0 minus 1 value. When we are taking the borrow, and the difference is also 1 here, right? Now we know output value for each combination. With these values, we need to find logic expression for difference and borrow. Initially I am finding a logic expression for difference, okay, for difference. As we are having 8 possible combinations, I am considering 8 cell K-map. With inputs A, B, C, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1 here. See, for the first combination, difference value is 0. So first cell 0. For 0, 0, 1 combination, difference value is 1. For 0, 1, 0 combination, difference is 1. For the next combination, 0. For 1, 0, 0, 1. 1, 0, 1, 0. 1, 1, 1, 0, and this is for 1. As there is no adjacency between values, I can consider these values as a single terms. Let's take this is 1, 2, 3 and 4. Now the difference value is, which is A, B bar, C bar, first term. The second one is A bar, B bar, C, plus, and the next one is, third one is A, B, C, and fourth one is A bar, B, C bar. Fourth one is what? A bar, B, C bar, right? Now, the first two terms, B bar is common, right? So, take B bar as out, then we will have A, C bar plus A bar C plus, in these terms B is common, so take B as out. We can write AC plus A bar C bar, B bar. This AC bar plus A bar C is exclusive OR function between A and C. Plus B. AC plus A bar C bar is exclusive NOR function. So exclusive NOR of C. Right? Now just consider A exclusive OR C is X. Then A X NOR of C is what? X bar. I am substituting here B bar into, this is X, plus B into A X NOR is what? X bar. Now in this equation also, B bar C this is what? B bar X dot plus B dot X bar, means this is also a B exclusive OR between B and X. Exclusive OR function between B and X. Now we know X value, right? X is what? A exclusive OR C. So from this, the difference value here we are getting as A exclusive OR B exclusive OR C. This is the logic expression for difference function. Similarly, we need to find the logic expression for borrow also. Right. Now, we will find the logic expression for borrow. As borrow is also for 8 combinations, I am considering 8 cell K-map for borrow. Here the inputs are A, B, C, right? This is logic expression for borrow. Now, for the first combination, the borrow value is 0. For 0, 0, 1 combination, borrow is 1, right? For 0, 1, 0 combination, borrow is 1. For 0, 1, 1 combination, borrow is 1. For 1, 0, 0, borrow value is 0. For 1, 0, 1, borrow is 0. For 1, 1, 0, borrow is 1. For 1, 1, 1, the borrow value is 1. For 1, 1, 1, the borrow value is 1. Right. Now, we just see the adjacent cells for 1. See, these two ones are adjacent together, so that I can make one pair. Again, these two ones are adjacent, so one more pair. Again, these two ones are adjacent. This is third possible pair. Now, the borrow expression becomes sum of these 3, that is 1 plus 2 plus 3. Here 1 is nothing but BC. As it is vertical, there is no common term in A. So BC. Second term is A bar is common for these two terms and B, plus for the third term again A bar is common and C. Right? I am writing this expression as A bar B plus BC plus A bar C. Okay. Right. Now we will know the expression for difference and borrow. Difference is what? A exclusive OR B exclusive OR with C, and borrow value is A bar B plus BC plus A bar C. Right. So I will develop the logic diagram. So as I am having 3 inputs, I am considering 3 input values, which is A, B, C, right? To get the difference, here we are having exclusive OR function. In exclusive OR function, only 2 inputs are possible. So initially I am considering one 2 input exclusive OR gate, so that I will get A XOR with B. Now I am taking third input C, which is given to one more XOR gate, so that we will get A or B with exclusive OR with C. This is sum. Similarly, to get borrow, here the first term is A bar B. So I am taking input from A and give it to one NOT gate, so that you will get A bar and B, one AND. Next BC inputs, take input from B and C, give it to one AND, so that you will get BC, A bar C. Take input from A and give it to one NOT gate, so that you will get A bar, and take input from C, so this is A bar C. Now these 3 terms are OR together. So consider one OR gate, give these 3 as inputs, so that you will get borrow expression, right? In this way, we can design full subtractor function using logic gates, right? This is one possibility to design full subtractor. Similarly, the full subtractor we can also design by using half subtractor also. We will see how it is.